All right, so far the biggest difference between sketching a linear equation and a linear inequality is that when it's an equation, we just have the straight line. Those points are our solutions. For an inequality, once we get that line, we have a shaded region. So we kind of split the graph in half and figure out which side includes all the possibilities. Once we get to a system of inequalities, we have two inequalities. They'll be graphed on the same coordinate plane. We're going to create 4 sections. So I just want to go through a couple examples. For this first one, y is greater than 4x minus 3. We still have the y-intercept and we rise 1, 2, 3, 4, run 1. I'll get another good point. 1, 2, 3, 4, run 1. And from there, since it's greater than, I know it's going to be a dashed line. So I'll try my best to fill that in as a dashed line. Remembering from earlier that we call it a boundary line. Let's see. So I'll add arrows on the end to show that it goes on forever. Since it's greater than, I'm already thinking that I would be shading this side that's above. With that one inequality, I've created 2 regions, and I'm shading the one that's greater than. I'm going to switch colors to show the other inequality. Since it's a system, we're graphing on the same coordinate plane. I'll start at positive 3 on the y-axis for my y-intercept. It's a negative slope, so I know I'm heading downhill. I'll drop 2, go over 1, drop 2, go over 1, and so on. Since it's greater than or equal to, I'll try my best to get a solid line for that boundary, arrows on the end. Okay, if this was just a system of equations, this point of intersection would be that one point that happens to work for both. But since it's a system of inequalities, we've created 1, 2, 3, 4 regions within our graph. So our task right now is to figure out which one of those works for both. If I focus just on this purple line here, y is greater than 4x minus 3. The 2 regions that were greater than are region 1 and region 4. For the red line, y is greater than or equal to negative 2x plus 3. Anything greater than this one would be region 1 or 2. So that means that region 1 is my area of overlap, and I would shade just this region. For this one, I just wanted to show it really quickly because I know some people are still struggling with this type of inequality. If y is greater than negative 2, I'm going to find y, my y-axis, I'll find negative 2 right there, and I'm going to draw a line so that I can see it. If I drew a line straight up and down, that's the y-axis, I wouldn't be able to see the line, so I'll go straight across, keeping in mind really carefully that it's going to be a dashed boundary line. All right, and any y values greater than negative 2, so that includes negative 1, 2, 5, anything above that boundary line is good to go for my system. Colors again. For this other one, I'm hoping we're okay with graphing inequalities like this. Positive y-intercept at 3, negative slope, so I know I'm heading downhill. I'll drop 5, head over 1. So again, if it was just a system of inequalities or just in a system of equations, that would be my solution. But I'll graph this line. And now I have 4 regions, and I'm trying to figure out which one works. Anything greater than the blue line is anything up here. Greater than my green line is going to be over here. So I would shade this region. You could always pick ordered pairs. So for example, I could pick 3, 3, and test it. I think for a lot of you, that's going to take more time than it needs, and you'll be fine with this type of work.